You are audible.
Okay, Mr. Thank you so much. First of all, I would like to give my heartful thanks to all the members, the authorities for giving me a chance, opportunity to present my the findings. So, myself, Devanusi Datta. Good evening to all. In Indian, it is 1:24 p.m. at Indian time. So actually, I am a assistant professor at Assam Agriculture University, but I would like to present some of the findings during my PhD work. Uh, the work is still going on. This one is synthesis, characterization, and antimicrobial activity of gluconate stabilized silver nanoparticles, again Penicillium italicum. Can I proceed, madam?
Yes.
You are audible. Just continue.
So we also study silver nanoparticles had a wide antimicrobial activities. It is widely used in medicinal, not only medical purposes, but also the different plant pathological aspects. We're using the silver nanoparticles. But we are synthesizing gluconate stabilized silver nanoparticles. And this synthesized nanoparticle, we are testing against one of the most potent, the post-harvest pathogen, that is Penicillium italicum. It is known as the blue mold fungi, and which cause that one fruit rot, that, especially the Khasi mandarin. The work is doing at Meghalaya. So the Meghalaya is famous for the Khasi mandarin, and for which it is retaining the GI tag in the year 2014 for the Khasi mandarin. And this species, the Penicillium italicum, causing a havoc in during the stories of the that Khasi mandarin. So keeping this in mind, the present investigation was carried out with the two objectives. Number one is the synthesis and characterization of gluconate stabilized silver nanoparticle, as well as to see the efficacy against the Penicillium italicum. So this is the methodology. For synthesizing, we are following this one, sodium borohydrate reduction method. The chemical method we are following for this, we are using sodium borohydrate as well as sodium D-gluconate, and we are using silver acetate. First, we are preparing 1 millimolar solution of sodium borohydrate, then 1 millimolar solution of sodium D-gluconate. Then they are mixing thoroughly. Then we are using a pipette and micro pipette, and 1 drop per 5 seconds. We are using silver acetate to that mixture. And in the condition is that the temperature is 40 degrees centigrade, and the RPM with the magnetic stir, that is the RPM is at 400 RPM. And during the stirring process, we have noticed some of the color change, because the initial color was found as yellow, and slightly it is moving to the brownish in color. So these color changes give some of the indication that the silver nanoparticles may be synthesized. For further confirmation, we are going for characterization with different instruments like SAM, EVBS, FTIR, like that. These are the different instruments we are using for characterization. And this, after finalizing that, yes, our particle is synthesized, then we are moving for the efficacy testing against the most potent post-harvest pathogen, that is the Penicillium italicum, and for which we are maintaining different concentration right from 1 to 5,000 ppm against the Penicillium italicum. So these are the treatment combination we have followed. This Penicillium italicum we have identified, isolated and identified from the Khasi mandarin itself, and it is available in the gene bank. That culture is already deposited. Then coming to the results, that is we have, as I have mentioned, that is the color change we have observed from yellow, light yellow to the brown. And this brown color gives some of the indication that our silver nanoparticles may be synthesis. And for the after that, for confirmation, we are moving for UVB spectra, which give a sharp peak at 410 nanometer. And generally, silver nanoparticles shows a peak from 350 to 500 nanometers. So we are attaining at 510 nanometers. So it gives some of the hints that it may be synthesized. Then we further with confirmation, we go for data sizer. Then DLS study, we have found that the size is 94.10 nanometer. Then negative data potential is also we have attained at minus 15 millivolt. So negative data potential is a very good sign. It prevents the coagulation or the coagulation of the nanoparticles, so that we can give it can be stable or it can be stored for further purposes. Then we are moving for the SAM characterization, which gives the spherical nature. Then again the SAM It gives the crystallinity as well as size within the range that is below 100 nanometers. Then ACSE pattern we have also observed. Then the clear fringes we have observed in HR term which gives the crystallinity of the synthesized silver nanoparticles. So we have confirmed that gluconate stabilized silver nanoparticles is synthesized. Then with that synthesized silver nanoparticle, we are moving for the antimicrobial activity of the pathogen that is Penicillium Italicum. So last picture, that is left side last picture, that is I, this is the control plate where we have growth of the penicillium is maximum. We are following the agar-well diffusion method. One side, we all know what is agar-well method. One side we put the pathogen and other side we put the different concentration of the nanoparticles and it gives the inhibition, and highest inhibition was observed at 250 ppm, that is 58.23. That is the graphical representation. We have observed 58.23. That one inhibition, percent inhibition of the growth of the Penicillium italicum. So coming to the conclusion, in conclusion, that I have mentioned that is the synthesized gluconate stabilized silver nanoparticles were characterized with different instruments, that is SAM, etc. And we are gaining the zeta potential value is minus 15 millivolt and polydispersity index was 0.413. So this the synthesized nanoparticles is polydispersed in nature. Then average size is 94.10 nanometer and spherical in shape. The spherical nature is very much important. If it is a triangular one or if it is a rod-shaped one, it may be cause some of the harmful effects to the environment. So spherical nanoparticles has less harmer than this one rod-shaped or pointed one. So it is a good sign for our synthesized silver nanoparticles that during the testing regarding the antimicrobial activity, we are getting the highest concentration, highest inhibition at 58.23% at 250 ppm concentration. So in future, we can think for this synthesized gluconate stabilized silver nanoparticles can be used as a coating material because if Khasi maintained, if we are using this the gluconate stabilized silver nanoparticle as coating material, then it may prevent the infection of Penicillium italicum. So these are my findings, and thank you all. Participation, madam. Thank you. Thank you all.
Thank you, Dr. Dutta. That was a wonderful presentation. Please remember